For this problem, we're going to look at several relations to determine whether they're functions, and then we'll state the domain and range. We want to determine whether each of these relations represents a function. For each of the functions, we're going to state the domain and range. So we'll begin with part A. Here we're given a set of ordered pairs. To determine whether this is a function, we first look at the x-coordinate of the ordered pairs to see if we have any repeated values. So we have 2, 4, 6, and 8. Since we don't repeat any of the x values, this is going to represent a function because we can't get two y values for the same x since we don't repeat any of the x's. Since this is a function, we'll write down the domain. The domain is the set of values that make up the x-coordinates. So we'll have 2, 4, 6, and 8 as our domain. The range is a set of values that make up the y-coordinates. So we have 5, 6, 7, and 8. Now on to part B, we again have a set of ordered pairs. So we begin by looking at the x-coordinates to see if there are any repeated values. So we have 1, 4, -3, and 1. We've repeated this x-coordinate 1, so we now look at the y-coordinates. Here the x value 1 corresponds to the y value 3, and here it corresponds to 7. Since the single x value corresponds to two different y values, this is not a function. We'll move on to part C. Here we're given a graph of a relation. To determine whether this is the graph of a function, we use the vertical line test. Since we can pass this graph with a vertical line and hit it in more than one place, this is not a function because it fails the vertical line test. In part D, we're also given a graph. If we imagine a vertical line and we slide that, there's no place along this graph where we can hit the graph in more than one place, and so this is the graph of a function. The domain is going to be the set of all x values that would correspond to points on the graph, and we can see that the domain is going to be the set of all real numbers because the graph extends the left and right continuously forever. So we'll write that the domain is the set of all real numbers. For the range is going to be the set of y values for all the ordered pairs on the graph. And if we look at the graph, it looks like the smallest y value is at 2, and because the graph continues to go up forever, we'll say that the range is y greater than or equal to 2. So we have a function in part A, we have a function in part D, but parts B and C are not functions.